You've all heard of the theory of relativity, but do you really know what it means? To explain this theory, you have to first understand this. Objects move relative to each other. Say your friend Ben is walking on a travelator or a moving walkway, and you decide not to use a travelator and walk beside him. You have another friend, Lazy Larry, who's standing still. He sees Ben moving at 8 kilometers per hour and you moving at 5 kilometers per hour. What speed would you see Ben moving at? 3 kilometers per hour, right? But the thing is, even Lazy Larry, who's supposedly standing still, isn't, because the Earth, Sun, and even the galaxy are continuously moving. So nothing really stands still or moves absolutely. They just move relative to each other. So now that that's out of the way, let's talk special relativity. Let's say that you're in a rocket moving at half the speed of light, and in the same direction, a beam of light is shone beside you. You would think that you would see light pass by you at half its speed, but that's not the case. You would see light going at 300 million meters per second, because the speed of light is the same for everyone. But something has to be changing. That's time and distance. Imagine a light clock, a photon bouncing up and down between two mirrors. If you move it side to side, you will see that light has to travel a longer distance. But the speed of light and the time taken between every tick should be the same. So what's going on? What actually happens is that time slows down for the moving light clock. This is called time dilation. But there's more. Not only does time slow down for the moving light clock, but the moving light clock also becomes smaller. So the distance decreases. This is called length contraction. Now, let's talk about general relativity. The theory is basically saying that gravity isn't an invisible force that attracts objects to each other, but it's the warping of space. The bigger the object, the more it warps space around it. The warping also affects time. If Ben is at the top of the mountain and Lazy Larry is at the bottom, time will pass by slower for Lazy Larry than Ben. I know this theory may sound a bit hard to believe, but many tests have been conducted and this theory holds true. And it also has many real-life uses, such as recalibrating the GPS satellites to give accurate results. And if you're finding this really useless and you're late for class, you can tell your teacher that Einstein said time was relative, so maybe I'm not late and you're just early. Actually, don't do that.